Good morning, everybody. My name is William Grant. I'm excited that everyone's joined us this morning to talk about how we can enable our organizations with this idea of a citizen data scientist. I am a practice leader and principal consultant here at Technion. We do everything from building out data warehouses to doing predictive analytics to data visualization using some of the world's leading technologies. Joining me today, I also have Justin Swansberg from DataRobot. So Justin, do you want to introduce yourself real quick?
Excellent. Hey everybody, as Will mentioned, my name is Justin Swansberg. I'm a customer-facing data scientist here at DataRobot. What that really means is I work with our customers both pre-sales and post-sales, and I'm responsible for making them successful. We measure success really by whether our clients can actually use these machine learning models we help them build to drive business decisions. So we want to make sure they get from the modeling stage all the way to the implementation or deployment stage where they can start gaining real business value.
Perfect. Thank you, Justin. So today we're going to be this morning. Technical difficulties. All right, so this morning we're going to be talking about why are we continuing to see this term citizen data scientist pop up. It was coined, I believe, by Gartner a few years ago, but now it's becoming ever more important within our organizations, and the buzz is only continuing to grow on it. How do we make that transformation in our organization? How do we leverage it, and who's the right people in our organizations to do that? And if you feel like you're the right person, how do you turn into that? And so and then the last thing is just kind of an overall primer on data science techniques. So you're going to hear Justin and myself covering things like feature engineering, terms like regression, classification, and for many, or at least myself, 2 or 3 years ago, I had no clue what those meant. And so I figured it might be of some value and might help everybody kind of understand why is this world of automation very important. So kind of giving a background on that, and then jumping straight into a day in the life and using some of these technologies to solve a problem that hopefully some of y'all on the call have faced or be able to translate into what you do on in your daily lives. So that term, citizen data scientist, is becoming very popular, and a lot of it is because there's claims being made about artificial intelligence and how important it is. One quote I think that's very important and very relevant is you have someone like Elon Musk who probably leans more to the dark side on it, talking about how robots are going to take over the world, and if machines and things like that are going to be used. But then he's also has companies and organizations built around machine learning and AI with Tesla. And so I think this quote's very powerful in the fact of if you're not building AI, you're going to get crushed. And so that can be an outlandish claim, but that's backed up by people who are in this industry making forecasts consistently. And so this one by Forrester in 2017 says AI-driven companies will take $1.2 trillion from competitors. And I don't think the $1.2 trillion is the thing I would focus on. I think it's crazy that that's going to happen by 2020. And this prediction was made in 2017. As in, the artificial intelligence will drive the insights revolution. And so we're seeing that evolution of business insights and business intelligence being transformed into artificial intelligence or human augmented intelligence, or whatever the buzzword you want to say. If you're not on it already or not thinking about it, you're already behind the train. And so hopefully today's conversation will spark some interest in that and help you see why it's important to develop that citizen data scientist within your organization. If we dive a little bit deeper into that, why is that important? Is because there's only so many data scientists in the world, and the demand for predictive models that power the artificial AI programs and machine learning programs within your organization, and the need for that is far outpacing what we're able to produce with a data scientist. And so that gap is what we call the AI gap. And so the best way to fill that is 3 ways, or at least the way we see it, is first of all, invest in your employees and upskill them to allow them to understand and see the world and leverage that domain knowledge, and then automate all the processes that can be automated in your data pipeline. And then of course, self-service, allow people to easily access the data they need, be able to do and plunge and wrangle that data together to be able to leverage in your automation system. And so today, we always have this debate on where are we on this timeline, and I believe we're somewhere here, and it's only going to continue to see that pressure as 2020, 2021, 2025 continue to come around the corner. If we go a little bit deeper into that, what it takes to be a data scientist and why it's important is you have to have domain expertise. First of all, you have to understand the business, what you do on a day in and day out basis, and where that revenue comes from. And then you layer on, that same person has to have a plethora of programming knowledge, whether it's in R or Python. And then you talk about the libraries that are used in machine learning, things like H2O, TensorFlow, DMTK, XGBoost, scikit-learn. The list goes on and on. It seems like I read an article, a new article every week that talks about a new library that's going to change the world. And so that's something always having to be up to date on and how to leverage that. And then you come over to the math and stats side and how that makes sense. So, does everybody have a time to get a PhD in statistics to be able to fully analyze their models? No. And so finding that all together, it creates a unicorn situation, and that person is rare. And I would argue that if you don't have them, or if you do have them, they're going to get snagged and continually recruited to other places. And so the time it takes for that person to learn your business or domain and gain expertise in that industry takes a long time. And it's a big investment to retain them. That domain knowledge is very hard to teach, and there's people in your organization who already know that. And so leveraging the expertise you have can take you a long way with enabling with self-service tools. But then you can leverage technologies like DataRobot, which we're going to cover today, to help enable that client-facing data scientist. And so helping, we sent out, our marketing team put together an email talking about Clark Kent to Superman. And so I just had to go ahead and use this as a platform while everybody's on mute to go ahead and say Christopher Reeve is the best Superman and the only Superman. And so how do we allow people to transform in your organization to be those superheroes and leverage that? So the overall path to predictive, if you're not familiar with the pipeline, this is going to be a very high level overview, and it's, to me, kind of exhausting to read. The fact that, as a data worker, I have to get access to my data. I have to figure out all the other data sources I can join in my organization, and then I have to cleanse that data to make sure it's going to work within the models I'm going to leverage. So depending on the tool package or the coding language or the libraries I'm going to use, everything has a different cleansing process that it takes. And then I have to go through a process of feature engineering where I'm creating new attributes and new columns that allow those models to be the models that I'm going to create in the next step to be even more powerful. And then I have to go through the process of creating the models and finding the top models that are going to perform. And from my experience, most people have 5 to 10 models they like to leverage depending on a problem. And so they're not always refining the latest and greatest. And then you have to validate the models to make sure they're going to perform and that they're going to be accurate and that they're going to create the business value you're expecting, or being able to say, no, that's not where we want to go into production, and being able to go back and refine early on in the process. And then deriving insight. What is this model telling me about the way we do business? What is happening? What are the insights that are being derived that can help me enhance further future development on this model? And then finally, you get into production. But anywhere along that continuum, you can go back and repeat. And so oftentimes, this could be a 3, 6, 9-month process in kind of the current toolkit that a lot of data scientists are leveraging. And what I'm hoping you'll see today is that using the combination of modern technologies, that timeline gets much shorter and you can leverage the expertise you have in your organization. So kind of what we recommend is Technion, and what we oftentimes help our clients with is using the combination of Alterex, DataRobot, and Tableau. And for today's conversation, we're going to largely focus on Alterex and DataRobot. But Tableau, Power BI, all those other data visualization platforms allow you to be able to really derive insight. We just believe that Tableau really helps you take that to that next level and integrates very well with the rest of the stack that we have. But with Alterex, it allows you to find your data, join it together, access it, do some data cleansing, data prep, and then allowing you to contribute that business domain knowledge into your data and creating those features. And then with DataRobot, it allows you to build and validate models, but the really powerful part is with the automated creation of models and allowing you to always choose the latest and greatest and best performing model for the use case you're trying to do. And it creates and automates a lot of those mundane feature engineering tasks that we'll cover a little bit under the primer at the end of the slides. And so, Justin, I'm going to change it over to you real quick and allow you to elaborate anything from the DataRobot side.
Yeah, absolutely. Thank you, Will. I think from our perspective here at DataRobot, we want to do our best to automate, if you think back to that last slide, the math, the stats, and the programming. And I think it's intentional that we focused on those latter two aspects rather than the business domain, because that's the more automatable part. And you really do need, as Will said, all three together to build highly accurate models. Oftentimes, people just don't have the experience or the toolkit to build all of these different models, have an understanding of all these different libraries, the different types of approaches you can take, and really just the time either. So we want to enable people who are intimately familiar with their business, who understand the key drivers and the goals, essentially arm them with these new algorithms, and these new types of predictive modeling to help them get to those goals as quickly as possible.
Thank you, Justin. So we'll dive a little bit deeper into kind of what is the data science, what are some of these terms that we're using and you're hearing from us before we dive in. And so, Justin, do you want to talk a little bit about classification and regression?
Yes, absolutely. So I think in general, there are two ways to structure machine learning problems: classification and regression. And both of these approaches deal with how you want to frame the problem. So classification is predicting discrete valued outcomes. Think about predicting some value from a predetermined list of potential values. Whereas regression, it's predicting continuous valued outcomes. So any real number from a number line. In the context that we're going to walk through in the day in the life section, we're going to be predicting the likelihood that a borrower defaults on a loan. So that's going to be either a yes, a no, or a true or a false. And since there are different options here, this is going to be an example of a classification problem. If we wanted to structure this differently though, rather than predicting whether someone's going to default, we could predict, let's say, how much of the initial principal or interest a borrower will pay back. And since that's predicting a dollar amount, this is going to be a continuous variable. And now it's turned from a classification problem into a regression problem. I think another example could be predicting store sales. So if we wanted to set up a classification approach, we could predict whether stores would have high, medium, or low sales volume on a given day. And if we wanted to set up a regression approach, we could just predict the actual dollar amount of sales a store would sell on a given day.
Thank you, Justin. And so I think it's really key, because identifying that type of problem is very important. And a lot of times, you know, while Justin made it seem kind of simple, it can be confusing on the best approach and given the data set and the type of training data you're putting in to define it. And so that's one area that you're going to see that DataRobot kind of helps target and analyze what is the best approach. And so on my next slide here, we're going to talk about feature engineering. What is that term? Some of you are probably familiar with it, but I was not when I first came across that. And so it's really being able to leverage the domain knowledge and business expertise you have, along with some best practices for machine learning and the different libraries you have, to continue to use the data you have to extrapolate additional features or attributes or columns to make those models even more powerful, more accurate, and allow the predictive power to go up. And so we really view it as two types. There's the business knowledge to create additional features. So this could be figuring out how you want to aggregate additional data sources so that they can join together and blend together, figuring out how to parse fields within that data, or figuring out other ways you want to aggregate certain columns or provide that context to the data that the machine learning algorithms can use to predict. The other one is machine learning best practices, things like Hot Encoding, count encoding, breaking out date fields or doing text analytics to add additional features or context to that. And so largely we believe the first one, find an easier way to approach this. Don't raw code this, but use something that's scalable and allows your knowledge workers and your analysts to be able to extrapolate this context and be able to share that across your organization. And then automate the second way. Justin, do you have anything to add?
Yeah, I just say as far as that second type is concerned, these type of features that are typically hard to parse information out of, like text fields or categorical variables, are oftentimes super informative. So going that extra mile and actually trying to extract some information by any of these approaches, so the one-hot encoding or breaking down date fields or trying to text mine some free text, can really help improve models. And it's often the step that I've found most people skip. So creating a solution that will help you automate that can definitely help scale your machine learning capabilities.
Let's dive deeper into one-hot encoding real quick and kind of talk about that, because I think that's a very interesting approach and give some good context to what that means.
Sure. So I think one way to understand the need for one-hot encoding is that when you feed data to these algorithms, they're not really going to understand, per se, text characters. So in this case, let's say we are trying to predict the likelihood of loan defaults, and we happen to have information on the grade of the loan. So that column in the far left group might indicate the credit quality, and there are 3-letter grades, A, B, and C. By itself, a machine may not always know how to handle this. It doesn't know what an A means. It doesn't know how much worse a B is than an A, or even if it's worse at all. So one approach people take to actually convert this type of information into a numeric field is one-hot encoding. For group 1, imagine this is essentially creating an indicator or a dummy variable that just flags whether or not this particular loan had a grade A. So you see every row of 1 pops up also corresponds with an A in that leftmost column. And the same thing for groups 2 and 3. Group 2 here would just be a flag that's alerting the model, hey, this loan is a grade B loan. All the other ones have values of 0. And then for group 3, every time a 1 pops up, I'm now informing my model that this loan would have a grade C. And so you're going to have as many additional columns as there are unique values in the initial field. And this is just one potential way to handle this situation. Once we actually hop into it, you'll see DataRobot tries out a whole bunch of different encoding techniques and actually test them out in the data to see which one works the best.
And I think that's the powerful thing, is because each model has its preferred way of feature engineering being done and expects its data to be in a certain way. And knowing that can be very difficult because every library, every specific model has a different way. And so, you know, DataRobot already has the preparation steps taken to make sure that it's encoded and features are engineered in a way and the data is cleansed in a way that's going to work best for that model to get you the most accurate prediction. Another thing that's helpful that can be done, that DataRobot does for you automatically, but provides some additional context to feature engineering that I like, is thinking about dates. And so if I want to add another way to look at dates and help enhance my machine learning model to be able to understand what's happening in dates, is taking things like, we have this data set here that has manufacturer date and whether something was defective. And so we see that on 10/6 it's true, on 10/12 it's true, but every other day it's false. Well, one way we might encode that and add a different feature is day of the week. And so in a data visualization, Tableau, Alterex, you would typically, this would be some way you would analyze that data. Go ahead and add it to that data set and allow that model to continue to learn off of it. Best thing about DataRobot is you don't have to worry about that because it's going to automatically do that as part of its date processing if you have dates encoded. So Justin, anything to add there?
Yeah, I think that's right. The only other thing I would add is DataRobot helps automate this process as well. So if you did load in a new data set with date time information, it's going to extract features like day of the week, but more than just that, it'll also take out things like the actual week, the month, the number of days into a month, essentially testing out what is it about this date feature that might have some predictive impact? What can help us better predict, in this case, borrower defaults? My favorite example of feature engineering, at least in this context, is let's say we had information on a borrower's total debt and total income. Not every model might learn off the bat that it actually might be more appropriate to model debt to income ratios rather than their total debt and income separately. So you'll see that DataRobot will actually take ratios for you to see if those can help improve predictive performance. And that one's sort of intuitive because maybe it's more helpful to know how much debt someone has as a percentage of their total income rather than just how much debt in general.
That's awesome. Thank you, Justin. So let's jump into the technology. Probably the reason why most of us are here to do that. And so I'm going to press escape as you're going to see me go through it. And so what we're going to be working on in today's data set, and Justin alluded to this, is trying to predict which one of my loan applicants are the most likely to default. And so this is a publicly available data set. There's nothing special out here. But what I have is a data set around loan applications, and I have some information that I might want to grow it on. So if we're looking at this data set, I see I have kind of a row ID, I have something listed as target, or this could be called default, how long they're likely to default, name of the contracts, and different codes, and all the different types of things that you would typically see on a loan evaluation. And just like this, I could take this into DataRobot and it would automatically go ahead and mark this and start building models off of it that would be highly accurate. But as we talked about with feature engineering and some data prep, it's important that you add as much context to this as possible for that machine to learn off of and for models to be created. And so I have another data set over here called Bureau that has some different credit score information about each one of those applicants. And so I have my ID, I have a Bureau ID, you know, how many active accounts, closed accounts, things by it, and I can see that it's at a different grain. I see that, you know, this 10,002 ID number has 8 different values in it. And so we need to do some work to get this put together. And so that's why using a technology like Alterex allows you to really put that together. And so let's go ahead and roll over to Alterex and open up a new workflow. So I thought I had one created. Boom. All right. So now what we're going to have is I'm going to have, this is Alterex. This is a canvas. You're going to see me interacting with it. Across the top are different tools and processes that I can use on my data. On the left, I have a configuration pane that you're going to see me adjust some things on as we get further into the workflow. And on the bottom is my results window, or what I can see the action steps that have happened on my data and how that's coming together. And it's just a drag and drop format. So I'm going to take my input data, I'm going to drag it onto the canvas and drop it. I'm going to go ahead and connect to my application file. So I have this application file here. It's in Excel, and I'm going to load that up. And I'll drag a browse on it, which allows me to see into that data. I'm going to press play, and it's going to run and load that data into memory. So if I open it up, I can see all that data that we just looked at in Excel has made it in, and Alterex has gone ahead and done some data profiling for it. So I can see how much of that data is good, how much of it is null, and so forth. And we have a lot of columns here, which is going to be great for DataRobot, because the best thing you can do is throw as many columns on it as possible, because DataRobot is going to figure out which ones matter, which variables are informative, and even creates its own feature list as well based on that data. So we're going to go ahead and close that. And so now I'm going to bring in that Bureau data set as well. So I'm going to go over here to Input Data. And go to File. And I'm going to grab Bureau. Grab that Browse tool again. Let's go ahead and press play. So when I'm pressing play, it's going to load it into memory. And so now I can see the same thing. It's gone ahead and profiled it. So I have this credit active. I have some credit currency. I have some different measures. Again, this is at a much lower grain, and so we have to figure out how to get it up to that same level as well. And then I have this thing called credit type. And so let's go ahead and look at credit active and see the different variables. So one of the first things I could do as far as feature engineering, or to get this up to a different grain, is roll this up and do some counts by closed, by active, by sold, and bad debt. And I see sold and bad debt, there's a lot less. 428 are sold. Bad debt there's only one in this data set. So overall, the data looks great. And so the first thing I'm going to do is I just want to go ahead and bring out a summarize here. And we're going to work on some transformations. And so for that summarize, I'm going to group by, which is just going to say I want everything I do at this level of grain by our ID field. And then I'm going to go to credit active. I'm going to group by that as well. And then I am going to go to and make a count of each of those. And so once I'm done here, I'll show you what that does. So now I can see I have everything by ID field, how many are closed. And then, for example, this 10,082, they have both active and closed accounts. They have 5 active and closed 12. And so what I want to do is cross-tab that or pivot that up so that I can have it at that same level across the board. So I'm going to group the data by the current. I'm going to want to make the header row credit active, and I want the value field to be count. I'm going to join those to my application list. Select and join those together via the record ID. And then I can deselect any extra fields. So keeping your data clean as well is helpful. And then I want any records that don't join from the application list still to be in that final list. So I'm going to go and union those together, which creates, that combination creates a left join. And press play. All right, so what we have here is we can scroll all the way over to the end and we can see those fields it's joined up by. So this record here has 5 active and 12 bad. This one has 10 active and 3 bad. One other step I would take is ratios, like Justin talked about earlier, and maybe active to close, things like that. But I don't need to worry about that because DataRobot is going to take care of all that for me. The next thing I might want to do is do the same thing, but I'm going to do that on that other field we looked at. So if we go to all the way over to the right, I see credit type, consumer credit, credit card, consumer credit, and just do the same count. So I'm going to group by SDK, the ID field. I'm going to come over here to credit type. We're going to group by that, and we're going to count on that. We're going to cross tab. The nice thing about Alterex is that you don't have to press go every time. It's automatically going to save or pass that metadata through. And so when it does that, I don't need to press run to continue the process of going. And so that just allows me to stay in the flow longer. And so I'm going to join that back up. Click on the ID field. I'm going to scroll down here and uncheck the ID field coming on the right. We'll do a union to bring over any unjoined fields on the left side. And let's put a browse so we can look and make sure everything came across appropriately. So it's going to run, and I have 12,143 records. That's the same amount of records that came from the beginning, so I know everything's coming together appropriately and I'm not losing any data. The last thing we want to do is aggregate the rest of the fields. And so if we look at the bureau, we see there's many other fields that we can add to our data set. But since it's at a different grain, we have to figure out how we can logically make sense of that. So what we'll do is we'll go ahead and the first thing we'll do is we'll bring in an auto field. And since this is coming from a CSV, it doesn't have any data type information on it. And so the auto field looks across that data type and chooses the best and smallest data size that it could possibly handle to make the workflow as efficient as possible, but making sure things that are numeric are recognized as numeric and things that are a string are recognized as a string. So I'm going to go ahead and connect that to auto field. Since it's a string in my application data, I don't want it to impact any of my ID fields. So I'm going to uncheck those, and then we will press play. And then talking about different things that Alterex is able to connect to, there really isn't a data source I've not been able to connect it to. It has different ways of connecting to APIs, Excel, Hadoop, databases, and it even can help you write in-database queries as well. So now that that's finished, we can look at the metadata and we can see that it's changed everything from a string to the optimal data type. So we see some integer 32s, integer 16s, some doubles. And so it makes it very efficient so that we can work with that and build some formulas. And so the next thing we're going to do is we want to go ahead and make it to where we want to focus primarily on active accounts. So we're going to filter this and filter out all the closed. So I'm going to come over here to preparation, drag down filter, come over here to credit active, and I'm just going to type in active. That's the field we want to filter to. We can do a custom filter that has a lot more logic in it, but it's automatically created that based on this basic filter, so we'll leave it there. And so I'll just run it so you can see what's happened along the way. So we can see that everything in that credit active field is just active, so it did exactly what we wanted. And then I'll come over here to the transform, or we'll write a quick formula actually, and I'm going to create a flag for the days overdue so that we can know that if there's any days overdue, that we just know that they're late in general. So the first thing I'm going to do is add a column. I'm going to call it credit overdue. And then we'll just write a simple if statement. So if credit day overdue is greater than 0, then 1, else 0, and if. So it gives us a preview, so we know we're not going to have an error. And now what we show is here, we'll show the flag. So here we know that they have something overdue. All right, and now what we want to do is bring that up to the regular grain that we're working with in the applications list, because that's what the prediction is going to be on. So a way to do that is to do some different transformations. So we'll grab a summarize tool here and use that to do it. So I'm going to grab my days credit and my credit days overdue. First thing I'm going to do is actually do a group by. I apologize. Days credit and days credit overdue, and then I'm going to first do an average of those. And then I'm going to do a median, max, and min. You don't have to put too much thought behind what's going on, because DataRobot's going to automatically choose which one of these has the most predictive power. And the sample and the amount of applications in the application list is large enough where it's going to be accurate to be able to predict those. So it's just good to grab and roll up as much as you can to that higher level grain. The next field we're going to grab is amount credit max overdue. Right there, and I'm just going to choose a max of that. And then amount credit sum overdue. And we're going to do a sum max And why the heck not? Let's do an average as well. Average credit sum. Do a sum, a max, and an average. And then sum credit limit, we're going to do a max of that. And we'll grab debt as well. And then we'll take that field we created, credit overdue, and we'll just do a count on it for non-blank. So that's going to be under string and grab count non-blanks. And so just like that, we've created a plethora of different metrics that we can roll up and add to the grain that we've created. And so we'll run that and just make sure it's landed before we do a join. So we see we have 10,720 records, so not quite 12,143. That's okay, because we're going to do a join to join that in. Not everything has a match from a bureau. But we have a pretty good data set here. It's at the correct grain from what we see here. So we're going to join that in. So I'm going to do a join. I'm going to grab our ID field, and then I'm going to uncheck that other ID just to keep everything clean. Go grab a union. And now I could write this out into Tableau, or I could push this out to an Excel file or a CSV and drop into DataRobot directly. But I'm a big fan of staying in the flow and in the move. And so what I'm going to do here is I'm going to go to Predictive Tools. I've installed the DataRobot Auto Modeler and Predictive Tools from the Alterex gallery. So I'm just going to grab the auto model, and I'm going to drag that into the interface here. Drop it. I have my DataRobot host. I'm going to grab my token ID. We're going to pause while I do that real quick. Sorry, I didn't quite get it all in. I'm going to name the project. We're going to call it CS2. And then I'm going to select my target variable. The target variable is what we want to predict. Go ahead and unpause it. So we have all those set up. I'm going to click off. And then we're going to come over here and grab a browse tool. If I entered everything in right, we're going to press play. And it's going to go through the process we built. And then it's going to send it via API to DataRobot. So it's just finishing up on my side, Justin. So the nice thing about DataRobot is it allows us to collaborate. So we're going to go over to our DataRobot. I'm going to come here. The project. We should see CS2 pop up soon. There's CS2. I'm going to switch over to that project, and then I'm going to go to share, and I'm going to invite more users. So I'm going to go to justin.swansberg@datarobot.com, and I'm going to invite him. And so what it's done is it's gone ahead and uploaded the data set, and it's creating the CV. I could also still remain in Alterex, and so I can see it's 65% of the way done as well. Justin, have you received the link?
I have. Thank you.
All right. I'm going to go ahead and make you a presenter. Or you should be presenter now. So I'm going to...
And let me know if you can see my screen, Will.
I'm not able to yet. Okay, now I see your screen.
Awesome. So I want to just quickly recap where we've been, what we've done, and then highlight where we are now. So Will walked us through that data set. And if y'all remember, the goal here is imagine a situation where we're processing a whole bunch of loan applications. We want to use this historical data we have to make a decision about whether or not to extend financing to new loan applicants. So we want to predict the probability they default, and hopefully, if our model is good enough, we can weed out borrowers that are highly likely to default. So what you're seeing now is DataRobot's web application hosted in the cloud, and all the setup steps that you'd normally walk through here through this point and click interface, Will already went through in Alterex when it kicked off that auto modeler. The first step when you upload a project to DataRobot is actually to take a pass through the data. So this is all information that came from that finalized CSV. And DataRobot's actually going to calculate a new metric called feature importance in this column here. This is going to be a cursory initial pass and attempt to figure out the strength of the relationship between each of the features and our target variable here, whether or not a borrower will ultimately default. So this measure here can really help you get a good initial idea as to which predictors might have some high predictive ability. It's going to actually rank them by that metric. So the larger the green bars, the more predictive. The other thing about this particular screen is it lets you drill down a bit more into these features. So let's say we're interested in occupation type here. If I click in and I sort it, you can start to get some extra information. So the blue bars are going to be a distribution of occupation type, and those orange circles are going to be, for each job type, the average default rate. So you can see here it looks like accountants are far less likely to default than people with other occupations. And you can
Hey, Just, sorry
Yes.
to interrupt real quick, but would you mind zooming your screen in just a tad? Just to make it a little bit bigger.
Yeah, just let me know when that view is right.
See if you can just go full screen. That might do it. Let's just go with that. Let's not pause too long. Sorry.
Yep, no worries. So I mentioned that first pass through the data is the first step. The second step is actually to review the data, all types of features, whether this is a regression or classification problem, and the distribution of that default feature we're trying to predict, and actually recommend a whole bunch of different modeling processes to try out. So on the right-hand side here, this is the queue. This is actually the result of that last piece where DataRobot went through your data and then recommended the most appropriate modeling strategies that we expect to work the best. And this is a big piece of that automation. So if I actually switch over to the Models tab now, once models are built and trained, they'll pop up here and they'll be ranked on this leaderboard according to how well they perform. So one thing I want to highlight here is that DataRobot is going to automate a whole bunch of different types of algorithms, and they're all going to be implemented from different libraries as well. And so this is one of the things we touched on earlier, where if you were a data scientist doing this manually, you need to learn how to program in a whole bunch of different languages, and you'd also need to structure your data differently every time you ran across a new algorithm or a new package. The goal here, or the idea, is to cast as wide of a net as possible, so we expose this problem to as many potential solutions, and then compete them against one another to see which one ends up solving this particular problem the best. You can see up top here that you can read that we've actually already built and trained 57 models on this data set that are all trying to predict default rates. After all these models are built and trained, and they all populate in this leaderboard here, the next natural step is to start evaluating them. And we actually already have this same project finished. So rather than waiting here, I'm actually going to hop over to this model, built in the same data, but with all the projects completed. So in this case, once that process is finished, DataRobot will actually tag models in terms of which one's the most accurate. And if I scroll down, it'll recommend a model as well. And for any of these models on the leaderboard, you can click in to get a better understanding of what's going on behind the scenes. So a big theme we stress here is making these models as interpretable and transparent as possible. So this is a gradient boosted tree. It's from Microsoft's DMTK package. And if I wanted a better understanding of what was happening, I could click on it, and the first place I'm brought to is this blueprint. So again, these modeling processes are more than just an algorithm. They're actually a combination of a whole bunch of pre-processing steps, that encoding we talked about, the date feature extraction, as well as the algorithm itself. So here you can see we're going to encode categorical variables. We're going to clean up some of the messiness with the numeric values by imputing missing values. And we're going to feed all that in to the actual algorithm itself. Different blueprints will have a different set or recipe of pre-processing steps that both help you possibly improve the model's predictive performance, but also conform to whatever library's specific requirements are. I think the next natural step here is to dig a bit deeper and evaluate the model's performance. And with DataRobot, there's a number of quick and easy ways to do that. So if I hop into this evaluate tab here, the first place we go to is a lift chart. If you're unfamiliar with lift charts, the idea is that these models all output probabilities that a person will default. So numbers between 0 and 1. If we were going to rank all these applicants by their expected riskiness and then sort them, we'd get on the right-hand side here the top 10% of applicants that we'd identified as being most likely to default. And then on the left-hand side, the bottom 10% of applicants that we'd expect to be the safest. So what's nice here is for each grouping or bucket, we're actually plotting in blue the average default rate our model's predicting, and then in orange, the actual default rate. So this gives you an easy tool to compare how well your model is performing across subgroups. If we were deciding to extend loans, we might be interested in only extending loans to the safest borrowers. So maybe we're particularly conservative. We'd be more interested in how well our model performed on this left-hand side here, and we'd be less concerned that the model starts to diverge as you go further right. And one last feature I like to highlight here is you can actually get even more granular as well by changing the number of bins. So right now this is broken down into deciles. If we wanted to double the number of bins, we could, and you can see you start to see some additional variance. So typically people look here to see how closely these two lines track one another, and also how steep this line is. The idea is that when your model predicts a borrower to be risky, you want these predicted values to be as high as possible. So that general steepness is also important. Another way to drill down on model performance is to investigate the ROC curve. This is a pretty standard metric to look into for data scientists. Whenever we make a prediction, we want to know, will this borrower ultimately go on to default or not? And we do want to avoid the cases where we predict that someone will pay back a loan, but they end up defaulting, because those can be the costliest. This ROC curve here gives you a nice visualization of how good your model is at differentiating those high-risk borrowers from the low-risk borrowers. So it's going to help you report what's called an AUC, or area under the curve score, that ranges between 0 and 1. A 0.5 is essentially going to be a coin flip. So the model is going to randomly choose, and it really can't tell if a borrower is more or less likely to default. So the closer this line is to the top, a score of 1, the better your model is. This gives a clean single metric score to assess model performance. After you go through and you evaluate the performance of these models, I think the next step is to get a better understanding into the hows and whys behind the model. So what is it about these features that make an applicant more or less risky? How is the model handling them? What is it considered to be the most important or impactful features? To key on that, we could look at feature impact. Feature impact is a nice, easy way to display the features that most contribute to the model's overall performance. So you can see here, these are ranked in terms of the most significant predictors to the least significant. The top 3 predictors are those third-party credit bureau scores that will merge in Alterex in the beginning. And each of these features are going to be scored to a scale, where the top predictor will be scored to a scale of 100%. We also see things like the number of days you're employed, whether you own a car, the total amount of credit you have. So this is a good way to get at a high level helpful information about what's driving your model's results. If you wanted to dig in even deeper, the most granular unit we can look into is what's called prediction explanations. With prediction explanations, we actually let you look at the individual borrower level. And so this computation is going to take a second to kick off. And what you see when it's finished is for every prediction your model makes, we'll actually output the top reasons or explanations why the model made that prediction. And so in this case, once this is done, we'll be able to drill down and actually say, rather than credit score, for example, is going to be highly informative, we'll be able to say, for this particular loan applicant, the reason he or she is highly likely to default is because of factors A, B, and C. So maybe they're particularly young, they've had a high number of credit inquiries in the past year or so, and their income is below a certain threshold. This helps a lot with the explainability piece, as well as helping to answer questions for regulators. So oftentimes, when you fill out a loan form and you're declined credit, it's nice to know why or what actions you can take, rather than keeping these models a black box. So it's features like feature impact and prediction explanations that can really help you understand how your model is working and make sure you dig down under the hood to figure out what's making the model tick. Overall here, it looks like this gradient boosted tree was the recommended model. So typically you'd go through and evaluate each of these models in turn to choose whatever model you're most comfortable with. But I think for purposes of this demo, this gradient boosted tree looks like it's going to be highly accurate. Let's imagine we went through, we sanity checked the results, we were comfortable with the features. The next step is to actually use this model to score future loans. So when new loans come across my desk, I need to make a decision about whether or not to extend credit. So that's the deployment piece, and that's the second stage of predictive modeling. So I think at this point, I'll turn it back to you to show how you can use Alterex to incorporate these predictions.
Thank you, Justin, and thank you for that overview. So everyone on the call, we're about 2 minutes away from the end. We're going to keep going. Would love for you to stick around and join. If you have any questions, please post them to the questions while we're doing that. We'll do a few minutes of Q&A as well. You'll see the questions in the GoToMeeting slide. If you have to go and you want to talk more about it, feel free to shoot me an email at wgrey, G-R-E-Y, @technionusa.com, and would love to continue the conversation. And also, we are recording, so if you do have to leave, we'll be sending out an email with the link to the recording at the end so that you're able to review. All right, Justin, thank you for sending that over. I'm going to show my screen now. Sorry, everyone, I had to make myself a presenter. So for the sake of time, I'm going to come over here back to, I'm going to come back over to Alterex, zoom in real quick. And I have the workflow that we built before. And so what I've done is I've gone through the interface tools and I've built out what we call an analytical app that'll allow you to publish this to the Alterex gallery so that everybody in the organization can leverage this who has security and permission to do so. You just drag and drop just like you've done before and connect it together. And basically we just say select applications on the action icon, update the input data tool, and it's going to allow me to upload a file via the web browser to replace that. The same thing here. And then the rest of the workflow stays the same, except for on the DataRobot tool, we switched it out from the, sorry, go to predictive. We switched out from the auto model to the predict. and then we join in the ID number, and then we created a rendering or just a basic table that we can do that. And so we publish that out to the gallery. Here, and I can see I have the default predictor. When we look at that app, we go run, and then I can go to browse, and I can select a file that has not been seen before by the model. So I'm going to go to DataRobot, the name of this webinar. I'm going to grab my new application list. Press OK. And then I'm going to grab a new bureau list. And I'm going to press run. And while that's running, the key with this is not necessarily probably the way you would build an app in your organization. You would probably have this sitting in a database in SQL. And so you can use that application list to pull those bureau information directly. And so the interface questions can be very simple. The other thing that's often done, especially in fintech, is they go ahead and build a web app. So right away, they're entering via a web app their application, and then it goes off and inputs that data directly into an Alterex workflow that's all done via an API. And so you can interact with these gallery apps also directly via API. And so now I see I have my ID for the application ID. I have my prediction. We can see that 194664 is predicted to default. They have a 69% chance likelihood to default. And zoom in so you can see that. I can export this via Excel, Word document to PDF. And really this is about enabling that prediction. If we look at deploying the DataRobot via the API, it's very easy to get that information. I'm just going to go to Activate and show example. And here's the code that's behind the scenes. Here's my API token. Here's my project ID. Here's my model ID. And here's the endpoint which I call. And so it's very easy to incorporate the DataRobot, this model, directly into it, and then continually update that to make sure you always have the best model in place, as well as new information and new data apply. Because in most cases, the best the model is going to be is right when it's first deployed. So using the combination of the Alterex and DataRobot makes it really easy to apply this. I'm going to roll over and finish up a few slides as we're wrapping up here. And so in the email we're going to send out with the recording for this, we're also going to include a link to Alterex and a link to DataRobot so that you can test drive them yourself. The DataRobot test drive is going to have data sets already incorporated for you. But if you would like to go through a POC, we would love to talk to you more about setting that up and identifying the right use cases to do so. The Alterex is a license, 2-week license for you to leverage and use on your own data. Again, you download it. Please, we'd love to have a conversation to help you make sure you get the most out of that trial. And then we'll send out the link to the webinar over the next few days. Key takeaways and what I think is important for you to walk away with this today with is if you're not thinking about implementing or are not already implementing predictive modeling, machine learning, or AI, you're already behind the curve. And so think about the best ways the strategies that we talked about to be able to catch yourself up and allow you to leapfrog your competition. You're not going to hire your way out of an AI gap. Data scientists are very hard to find. When you do, they're very expensive, and the hiring area for them right now today, with all the hype, is very volatile, to say the least. And there's a lot of people, if you go on LinkedIn, that are calling themselves data scientists, and the jury's still on who's actually a data scientist. Just making sure they have domain knowledge of your industry, deep programming skills, and deep mathematical statistics skills are going to be necessary. And so it's more cost effective, and a better approach is to figure out who has the right domain knowledge already within your organization, who you can empower with self-service and automation to leverage that. And the last thing is we're here to help. DataRobot and Technion, we're here to work together for you and help make sure that our clients and customers are getting the best possible outcome, helping fulfill those skill gaps, and making sure that you can stay in front of your competition. If you have any questions or want to talk about anything that we discussed on today's call, please feel free to get with myself. My email is wgrey@technionusa.com, or reach out to Justin at justinswansburg@datarobot.com. I really appreciate your time and sharing your morning with us. Thank you. For now, do we have any questions?
Yeah, we do have one question around pricing and just the general framework of pricing, and maybe you want to talk about a cloud-based pricing versus an on-prem pricing.
So I think the pricing really depends on overall use case. Alterex pricing is right online. If you just go to alterex.com, pricing, desktop starts around $5,000. If you go through a 3-year subscription, it's about $4,000. And then depending on if you want to leverage the server and the gallery and things like that, it goes up from there. With DataRobot, the pricing really depends on if you decide to go in the cloud or go on-prem. Cloud is a little bit cheaper because it's a shared resource, but a lot of organizations start there. And then, of course, if security is a deep concern and you want on-prem, a lot of financial, HR, healthcare companies go on-prem. And so it really depends on the number of users, the number of models. But we would love to have that discussion in person with you. But I think that's a great question. As somebody who's been on that side, that's the first question I always ask. And I think that's all the questions we have. I'll stay online here for another 2 or 3 minutes to see if we have any other questions. So this question is probably more for Justin. Does model tuning on grid search or Bayesian optimization, can you basically tune the models using Bayesian optimization or grid search? That's how I'd frame that.
Yeah, we do the hyperparameter tuning for you, but we also display the values we searched and the values we selected, and then give you the ability to input new search values. So there's a tab I didn't highlight called Advanced Tuning, where all that information is stored. We don't use Bayesian optimization. We have our own internal smart search. But we will be as transparent as possible and show you all the values that we did search and the one we selected, and then ultimately allow you to override those selections or try your own out and see if they can improve the model.
And just to add to that, one thing we talk about on most webinars, and for those who have been on it, this is going to be repetitive, but for those who haven't been on some of our other DataRobot predictive machine learning webinars, the people behind DataRobot are some of the top Kaggle competition or Kaggle competition winners in the country. And so they have over 150 data scientists that are constantly pouring into developing the best approaches and developing the right proprietary methods to make sure that the models are highly performant and accurate and fast. Another question I think that just came across that you might be able to help with is how much of the data is partitioned for training, validating, testing? Does it default to the package parameters?
It does not default to the package parameters. It defaults to our own heuristics that we continually update. In terms of how to set up model validation, we will recommend a default for you, but you can go in and override that as well. So I think the default is 5-fold cross-validation with a 20% holdout, but you can change any of those options. In general, in DataRobot, you have a lot of control, but we do want to stress the automated piece. So we want to enable that citizen data scientist that doesn't have as much familiarity with how data science practices work. So we do set up a lot of these defaults in the background for you to help ensure that you're sticking to data science best practices. We sort of think of them as guardrails. That being said, for more advanced users, you certainly do have the capability to go in and change exactly how you want to set up sampling, weighting, the type of partitioning strategies. You've got quite a bit of optionality there.
Thank you, Justin. And then one question I have is, can you pay for DataRobot by hour or data crunching? So the answer is no. You get an instance, and then you can fully leverage that within the cloud premise, or on-prem. You're purchasing that license, and so you can use that across many different users. And then does DataRobot include the compute power, or do you need our own servers on AWS? For the cloud, it definitely includes its own compute resources. So as you're deciding the mix of seats and the mix of workers that you need to be able to, or how many models you want to run concurrently, it's going to automatically scale that for the compute power. So that's included. If you want to install on-prem, then of course you'll need your own servers, but we can work with you on the best configuration for that. I think that's all the questions we have. Again, if you have any more, you have our emails. We're happy to answer, and we'll be sending out a link with the recording shortly. I really appreciate you spending your morning with us, and thank you, and I hope this was beneficial. Have a great day.